Well, good afternoon, everyone. Well, thank you all for joining us today. I'm Ryan Siegel. I'm joined by my colleague, Sean Maurer. Today, we're going to be looking at HVAC requirements you should know. Note here, we're going to be looking at the 2021 International Energy Conservation Code as the basis for today's presentation. Everyone after today's webinar will receive an email with your certificate of completion. So that'll be provided to all participants in today's webinar. We do have also continuing education credits for AIA and ICC number, along with BPI. So as noted here on the slide, if you are a BPI member, when we provide you that certificate of completion, go ahead and let us know that and provide us the information so we can go ahead and get that reported for you. So, as far as the recording of today's presentation, along with a copy of the slides, will also be posted to our website. So you will be able to find that for you and your colleagues who may not be able to join us today. So what we're going to be looking at is, again, looking at the changes from the Illinois Energy Conservation Code as we move from the 2018 version of the International Energy Conservation Code to the 2021 version of the International Energy Conservation Code. Again, going to be covering 10 of the important updates for compliance as we move forward, and wanting to kind of understand how some of these amendments are going to be impacting everyone. So a little bit of background about who we are. The Smart Energy Design Assistance Center, we're part of the University of Illinois. We're an applied research program, and our primary mission is to reduce the energy footprint here in the state of Illinois and beyond. So our energy code trainings is one of the ways that we provide that. And do want to thank our sponsor. The Illinois State Energy Office is sponsoring today's presentation, and we are the Illinois Energy Conservation Code training provider as provided through the Illinois Environmental Protection Agency's Illinois State Energy Office. So do thank them for making today's training possible. We do have a technical support helpline, so if you run into issues that you're needing some technical support on for the Illinois Energy Conservation Code, be it you or a member of your team. This could be either for contractors, project managers, energy engineers and architects, even building owners and occupants. We are here to support you in the Energy Conservation Code. Can reach us at energycode@illinois.edu. We also do have an 800 number if you do need to reach out to us for a real quick question. But we do encourage everyone to use our email address, energycode@illinois.edu, which that allows for several people on our team to weigh in and provide a written response back to you, such that if there's any additional questions or that written response can be shared with the other people involved in that project as well, so everyone can be reading off the same sheet of music. We do find that people find that very helpful, particularly as you're going through plan review and inspections where there may be questions such that the contractors, the design team, and the code officials are all seeing the same answer together with that. So we also have several online resources at our website, smartenergy.illinois.edu/energy-code, which includes archive versions of our workshops and webinars, along with several online on-demand training modules. The big question that I'm sure is in everyone's mind is, when is the state of Illinois moving to the 2021 version of the International Energy Conservation Code as the basis of the Illinois Energy Conservation Code? It is continuing to move through the process. At the moment, it is projected to be sometime this summer. So for projects that are going to be applying for permitting this summer, perhaps somewhere in that July timeframe, you might want to go ahead and consider updating the design to meet the 2021 requirements. So again, this is based on permit application date, not necessarily the plan review and approval date or construction date. So those projects that are going to be already in construction for the summer, you'll still be on the 2018 version of the code. So, as mentioned, we do have several resources on our website. Mentioned our previous workshops, webinars, and our online on-demand training. Also do link to our technical support helpline. We do have some comments here from people who have provided some questions through the technical support line, and several of the nice comments we have received on that. We also have several resources and links to other documents, so you can come to our website, again, smartenergy.illinois.edu/energy-code to find those. So things like the Illinois Energy Conservation Code, Chicago Energy Transformation Code, the upcoming Illinois Stretch Code, which may be implemented beginning in 2024. So that's coming up here in just a few short months. Also, frequently asked questions. Do have a section of those, and checklists. So for those of you who might be needing the energy certificates for commercial or residential buildings, that would be under our checklist section, along with several energy code smart tips. So a lot of different materials that are available to you on our website. So part of our website does link to several of these other documents. So again, if you're trying to figure out where to go for the 2021 IECC or the Illinois amendments or the Chicago Energy Transformation Code, again, these will all be linked right off of our website, and we'll work to keep these updated, particularly as the International Code Council comes out with new printings. The link will update. We'll be planning to update our link on our website, so you're always accessing the most current printing of the code. So we do have a note here about that Illinois is slated to adopt the 2021 IECC with some amendments. These amendments, or several amendments, have been proposed and approved through the Capital Development Board back in June of last year. However, this has later been revised, and Illinois is proposing to remove any of those amendments that were weakening the code below the 2021 IECC as written. So there will be still some amendments for the 2021 version, but those will be a few amendments that are going to be strengthening the code as it goes forward. So that is in process, and hopefully will be approved later this year. So today is the last of our top 10 series webinars. So if you did miss one of the previous three in the series, it is archive there are archive versions on our website, both the slides and the video recording of the webinars are available on that. So smartenergy.illinois.edu/events to find those. So for those of you who may be interested in, or your colleagues may be interested in-person training, we do have a top 40 coming up, scheduled in June in DuPage County. So that'll be coming up in person. That's 3 hours for top 40, as you kind of guessed. That's kind of our 4 sets of top 10. We're kind of rolling into one. We also have a Building Energy Education for Architects series coming up. One later this month, another one next month, and one in May. So you can see the topics we're going to be covering. Next week is going to be significant changes as we move from 2018 to 2021 IECC. April, we're going to be looking at the 2022 Chicago Energy Transformation Code. And then in May, looking at the Illinois Base Energy Code, the Stretch Code, and the Chicago Energy Transformation Code, kind of looking at a comparison and understanding where some of those high-level differences are for different projects that you may be encountering across the state of Illinois. There's a brief look at what we're going to be covering today. With that, we're going to start off with a poll question to learn more about you all today and your how we might be able to help you. So starting off, what's your profession? Are you architect, code official, engineer, contractor, or other? Go ahead and post that in the chat if you select other. And the second question, how comfortable do you feel with the mechanical provisions of the International Energy Conservation Code? Do you feel you know them very well? You're generally familiar with them? You could use a refresher. Or the IECC has mechanical requirements? And for those of you who may also have difficulty using the poll questions, you can go ahead and put that in the chat as well. That works as well for us. We'll give it just another second here. It's like almost everyone is in. Okay. So it looks like everyone is about half of everyone is engineers. Good to see. We do have some architects, code officials, and contractors here. And okay, as far as level of comfort, yeah, about half of you are definitely feel you could use a refresher. A third generally familiar, and then the last little bit, feel that you know them very well or are unsure completely. So, but yeah, so that's good to have some sort of a basis of understanding how detailed people may want to get into. So, and with that, I'm going to turn it over to my colleague Sean. Take it away for our first little bit here.
All right, thank you very much, Ryan. So first thing we're going to talk about in the commercial HVAC systems is an expansion of fault detection and diagnostics. In the 2018 IECC, this was required for economizers. Now for the 2021 IECC, this has been expanded quite a bit to general mechanical systems. So if you've got a new construction building that's greater than 100,000 square feet or larger, then the whole HVAC system is required to have built-in fault detection and diagnostics. So you're going to need permanently installed sensors to monitor HVAC performance. So chillers, boilers, individual HVAC units, things like that. Those sensors need to sample the HVAC system's performance on 15-minute intervals and store those in a trending history. Need to be able to use that data to identify faults and report those to building personnel to assist in that maintenance process. Because we know that from all the SCADA systems we've looked at in our years doing building energy assessments, there's a lot of data in those, and it can be hard to parse out when there's an issue versus just standard noise and standard operation. So these systems are going to kind of build that into that overall system to help identify maintenance issues faster and get those addressed before they become a major energy drain on the building. A fault detection diagnostic system needs to automatically notify authorized personnel, needs to develop a prioritized list of those measures. So something that's having a major impact needs to be addressed first, something like a faulty economizer or a pump that's running in deadhead or something like that. So that maintenance personnel can target the things that are going to have the biggest impact first and then work their way down the list. Because we also know things build up over time. There's usually a backlog eventually in building maintenance. And so having that prioritized list helps get the big ticket items first, keep the system as efficient as possible, and then you address the other things as you're able. These fault detection diagnostic systems will also be able to transmit prioritized recommendations to remote personnel. So having a link to a support network for your SCADA system, the manufacturer or somebody like that. So that if you have a SCADA problem, they can also help you remotely troubleshoot the system and make sure sensors are working properly, the programming's correct, you don't have some kind of error in the code of the management system as well. Group R1 and R2 occupancies are accepted from this, but all other occupancies are required if they meet that size target to have that fault detection and diagnostic built in. Just an example of fault detection diagnostic impact on a building. On the left side of the screen here is what the trending screen looked like for a system. And on the bottom of that screen is the anomaly score. So this is the fault detection diagnostic system's method of determining, there's an error here that's not operating the way this should be operating. This kind of scoring is also how they determine prioritization for these types of systems. And then on the right hand of the screen is the impact it had to correct that issue. So you can see some pretty significant cooling energy savings for this. In this example was an economizer. But you start seeing this expanded now to the entirety of HVAC systems. Next one isn't really a change from the 2018 IECC, but we want to touch on equipment sizing just because this is so important for buildings. So the language is maintained from the 2018 IECC. There's not much different here, except that there is some clarification in that the 2021 IECC breaks out sizing for standard building systems, most general commercial buildings, and then data centers have their own equipment sizing standard that they must follow. And that's the ASHRAE 90.4 standard listed here. The 2021 IECC does modify it slightly. Section 6 and 8 have some tables in them that the IECC modifies those tables a bit from what the standard has. But in general, you're following that standard for data center equipment sizing. And then the IECC has also added a number of equipment efficiency tables. One of them is, or a couple of them are based specifically around data center equipment. So again, we just really want to stress how important this is for buildings. Particularly, we see in the grand majority of existing buildings that there's some level of oversizing of the equipment, and particularly with cooling systems, this can lead to humidity control issues and comfort issues. But it can also lead to poorer equipment performance and shorter equipment life. So we really want to harp on that. Proper sizing needs to be done for these systems. The 2021 has expanded their efficiency tables for multiple systems. So in the 2018 IECC, we only had 10 tables of different HVAC equipment types, and you had to meet those equipment efficiencies in order to be in compliance with the code in your buildings. But with VRF systems and hybrid systems, including DOAS, data center systems have specialized cooling systems. The 2021 IECC has expanded this, and now there's 16 different reference tables depending on the type of equipment and the application for those systems. So some of those tables contain new content, like data center systems and VRF with DOAS, things like that. Most of them contain the same content that we had in the 2018 IECC, and those efficiencies in a couple of places have seen some updates, but for the most part are about the same. One of the big things to note is that systems using COP, HSPF, SEER, those are updated now as of January 2023 to a new standard. And so there's a slight difference in the ratings of older SEER versus the new SEER and other efficiency rating systems. The expansion of these tables also adds a little bit of clarification for speccing the efficiency of different pieces of equipment. Since you're breaking out a cooling system specifically for a computer facility. They'll have slightly different requirements in a cooling system for a typical commercial building that doesn't have such high equipment loads in it. So I think at this point, we're ready for our next poll question. We'll go ahead and launch that. Our first question, which systems are required to have fault detection and diagnostics in a 200,000 square foot facility according to the 2021 IECC? There's multiple answers here that are correct. So pick all that you think are correct. Do the economizers need it? The central boiler and chiller plants, individual VAV boxes and zone controls, individual RTUs serving smaller areas of that building. And then number two, which is not a consequence of oversizing HVAC equipment, higher capital costs, equipment materials, poor humidity control, excessive wear from extended operating hours, or excessive wear from rapid start-stop cycles. Give that a couple more seconds here to get a few more responses in. Get a few more trickling in here, a couple more seconds. And if you do have questions as we go through our content, the slides, please throw those into the Q&A. We'll be happy to address those while these polls are running. Okay, we'll go ahead and share those results. So for our first question, all of these are correct answers. All of these systems, and remember, it has to be 100,000 square foot or more building. The entire HVAC system needs to have fault detection diagnostics built into it. So the central plant needs to be monitored, the economizers, individual zone controls. If you have small pieces of equipment serving small sections of the building, they're still part of that entire facility. Those would all need to be monitored and have fault detection diagnostics built in. As far as which is not a consequence of oversizing equipment, looks like most people caught on. Excessive wear from extended operating hours is the incorrect answer there. So equipment that's oversized tends to short cycle and has fewer operating hours. So the wear comes from start and stop cycles and not from run times. At that point, I believe I'll turn it back over to Ryan to cover our next section.
All right. Thank you, Sean. So talking about heat pump supplementary heat, these are often also known as heat strips, typically done through electric resistance elements. And so in the 2021 IECC, it's calling out that heat pumps with your supplemental electric resistance elements or heat strips need to limit the use only to when one of the following are applicable. So either the vapor compression can't provide adequate heat. So that's when the heat pump just runs out of ability to actually provide the capacity required anymore. This we're seeing a little less and less, particularly as more and more people are moving to cold climate heat pumps that can continue to provide heating down to negative 30 degrees Fahrenheit. But you might still run out of capacity and say, okay, during extreme cold events, the heat pump keeps going and it's going to provide everything it can, but it may supplement with some electric resistance heating. During times the heat pump is in defrost mode, obviously it's not going to be able to provide heating while it's trying to defrost at the same time. If the vapor compression malfunctions, or the thermostat has a malfunction. So one of those four conditions would have to apply anytime that electric resistance heating is running. So I added a few more provisions for that. As we note here, the 2018 kind of only called out this first one where the heat pumps just couldn't meet the heating load. So now they're providing a little bit more detail about what that actually means and entails. So and here we're indicating on this thermostat here, the system has gone into emergency heat, emergency or supplemental or backup. They call it a few different things here. So this could be any number of reasons. And this kind of makes sense that we want people to kind of know that, hey, something has gone awry here before you just get hit with a $2,000 electric bill. So something that they're really kind of encouraging, particularly as more and more people are moving to heat pumps, is really calling out and saying we really want to limit the time that the strip heat is running. So a new, slightly revised thing for the 2021 automatic start and stop. So previously it was auto start. The 2018 version had the requirement for the 2018 IECC. And what this is looking at weather adjusting start and stop times, because as the outside conditions, particularly as you get into spring and fall, where the outdoor conditions are not very extreme, the building A may not have drifted very far, such that I'm not very far from set point anyway to begin with, and the building can recover easier during these more temperate times. So with 2018, they had the auto start, adjusting that for weather. And then for the 2021 IECC, we're now adding auto stop. So here noting that this is different than auto off or your evening setback. And so what this is doing is, as you're coasting in, it's kind of letting the building coast into your setback or your overnight settings during your minimally occupied times. And it calls out that how to do this. So it's going to set back the thermostat 2 degrees before my typical scheduled unoccupied times, and allowing the building to coast into that evening time. So good question coming in from Jeffrey. Auto start, optimum start. Yes, that is also another name for this is optimum start. So this is kind of looking at optimum start, optimum stop type of approach. We want to make sure the building is ready when the occupants arrive, but we don't necessarily need to bring the system online the same amount of time beforehand every day. So obviously during the winter and summer, when I'm likely to have drifted and it's going to be a little harder to recover. So I'm going to want to start those systems earlier during those more extreme times. And as I get more temperate times, I don't have to start it as early. Economizers. So here we're updating some of these, added a new exception as we're seeing more and more VRF or variable refrigerant flow systems coming online. They've added an exception for VRF. Partially for this is because VRF oftentimes is highly efficient systems, so they're fairly low energy to begin with, such that the savings may not be able to justify having that economizer. So the 2021 IECC added an exception for VRF, where you have VRF with a dedicated outdoor air system. Then we don't necessarily need to have that economizer in place. So also, it was just a little more vague language. So this is another thing. Oftentimes, what we do find in the code is it takes about 3 cycles before the code really kind of dials in the language to this. And so this by here we are at 2021. This is now oftentimes where we've kind of dialed in what proposals from the 2015 IECC really were kind of driving at. So again, it was a little more vague in 2018, and so 2021 they made sure to be a little bit more specific about what that is. So. Economizer and fault detection. So here we're extending this a little bit more. So economizer, so this is for buildings that would not necessarily cross that 100,000 square foot threshold, that where you have to have the entire system monitored. But on smaller systems, we do need to make sure that we are monitoring that economizer. Because economizers can have a lot of good benefits when they're working well. They also can be a substantial penalty when they are not working correctly. So part of this is wanting to make sure that if we do have a failure and something faults out, that it lets people know. It says, hey, something is not right here. Can someone who is a technician go and troubleshoot this? So what the economizer fault detection is going to be looking at is supply return and outdoor air temperatures. May also include humidity, but particularly wanting to start with temperature and making sure that it's providing a status on what the operation is at the time. So is it an economizer mode or not? And making sure that it's reporting either temperature sensor faults, economizing not working correctly, damper malfunctions, or a lot of excess outdoor airflow. So as noted, failed economizers can dramatically increase energy consumption. I did have a building that I was working on at one time. It was a sizable building, but the building was I don't know, something like 90 degrees outside, and the building was in economizing mode because a sensor had malfunctioned, and the building was running around 450 tons of cooling. Once they identified, hey, we got an economizer that's not working correctly, they went in, turned the economizer off, and we dropped from 450 tons of cooling down to 150 tons. So that one sensor going bad was 300 tons of cooling that were getting consumed unnecessarily. So that really kind of shows how dramatic this can be. And here we're showing an image of a thermostat where it's calling out right on the display, hey, the economizer is in fault. You can get more information. The big thing is that these systems are letting people know that, hey, I need some attention over here. So part of this is looking at and may also include trend analysis. And so looking at this and being able to have some trend capability is always very nice. One challenge that we do encounter is systems that may not have been set up correctly. So here showing a few different types. Some of these are a little more analog, some of these are a little more digital, but it could be that something wasn't set correct. Unfortunately, with some of the more analog or some of these older controllers, it may be a little difficult to see and understand how those are working and what the actual settings are. We are now seeing more and more controllers out there having, some LCD displays that you can kind of scroll through and see what is the current status, what are these temperature readings, and check some of this programming as you go. This is something that hopefully is part of the reason, and this is part of the reason why the code also requires commissioning of buildings, is to try to catch some of these as you go through. So trying to identify and say, is this sensor giving me an accurate reading? If it's it's 80 degrees outside and the sensor goes through and shows you and says, hey, I'm reading, 200 degrees. Okay, I definitely have a failed sensor. But whereas with the old analog controllers, you might have to understand, okay, what is the resistance of this sensor supposed to be based on the temperature, and I'm going to have to do a lot more physical checking on that. So here, noting that if you either skimp on or fail to do some of the commissioning, oftentimes it's not uncommon where these errors aren't found until retro commissioning or HVAC tune-ups are done, and really dig into this and start to look and say, is this reading correctly? Is it not? What is that? So fault detection and diagnostics for the economizers where required, saying, hey, those need to kind of read out somewhere. It doesn't necessarily have to go to a building automation system. As we saw in the previous slide, it could even be right on the face of the thermostat to just say, hey, something's wrong. Someone go look at the unit here. So with that, I believe we've got another poll question. Looking at the 2021 IECC, the 2021 IECC does not allow heat pumps to operate the compressor and supplemental heat at the same time. True or false? And number two, why are VRF systems exempted from the economizer requirements? Is it that heat pumps are very efficient, so an economizer is of minimal benefit? VRF can recover energy internally, so free heating and cooling is already accomplished by the system. Maintenance of multiple smaller economizers is too expensive, or VRF systems don't draw enough outdoor air to efficiently economize.
Did have a question come in regarding ComCheck Desktop. ComCheck Desktop is no longer supported for updates. So I believe the 2015 was the last update that the desktop version got. ComCheck and ResCheck are both going to online applications, and those both do have 2021 compliance reporting included. So DOE is phasing out those desktop apps and moving towards the online applications for both of those programs.
That also brings up a good thing is I believe they have also recently released ComCheck for the Chicago Energy Transformation Code as well. So that's something else. Not only do they have IECC, but they also have Chicago Energy Transformation Code on there as an option.
I also had a question here about are dry bulb economizers still allowed? Yes, you can use any style of economizer. It could be dry bulb, differential dry bulb, enthalpy, or differential enthalpy. There's a table in the IECC of what requirements are for specific set points for each of those in the economizer section. But yes, you can use any style of economizer. Okay, looks like most people have responded to the poll, so we'll go ahead and share that.
Okay, so does the 2021 IECC, okay, so it says, does the IECC not allow the heat pump to operate and the supplemental heat to operate at the same time? That would be incorrect. So that's false. IECC does allow both the heat pump and supplemental heat to operate at the same time. So it may be such that the compressor doesn't have enough remaining capacity that the supplemental heat can then come on, but it has to try to have the compressor run it first. So, second question: why are VRF exempted from the economizer? It is the first. It is the first one. Heat pumps are very efficient, so the economizer is of minimal benefit. Many VRF systems also are heat recovery, but not always. The second one, I could That would also make logical sense too, but that may depend on the type of VRF system that you pick up on. So it looks like most people picked up on this. These were definitely a little more tricky.
Reading articles on the VRF systems, the intent is that you don't have an economizer because the VRFs have that 3-pipe heat recovery system built in. If you don't have that, you should technically still get benefit from an economizer, but the energy code hasn't built that language in to the code language yet.
We're on the second cycle of 3 at this point.
We did get a nice note from one of the engineers and staff. Technically, you can use dry bulb for economizers, but with fault detection and diagnostics, those require the return air sensor. And so that kind of pushes you towards using a differential style economizer anyway, either enthalpy or dry bulb. And so a lot of time those economizers that have fault detection diagnostics built in are the enthalpy style already. So thank you for that feedback. Okay, so the next topics we'll get into are ventilation and exhaust systems. So within the ventilation system, we touch on demand control and ventilation requirements within the energy code. So what we're looking at here is that in the 2018 IECC, DCV was required for spaces greater than 500 square feet with an occupant density of 25 people per 1,000 square foot or more. In the 2021 IECC, they've made that a little bit more stringent. Now that occupant density is 15 people per 1,000 square foot or more. So they've started a slightly lower density there that triggers that demand control ventilation requirement. The square footage requirement hasn't changed at all. The other requirements as far as the systems have to be served by an airside economizer, have to have an automatic modulating outdoor air damper or a design outdoor airflow of greater than 3,000 CFM are unchanged from the previous code cycle. The only additional stringency is this occupant density trigger for demand control ventilation. On the exception side for demand control ventilation, there's been some changes here. Bold text highlights where those have been updated from the 2018. So 1 through 3 here are about the same, a little bit more stringent for bullet point number 3 on that CFM target for the economize or the DCV exception, reducing that from, I believe it was 1,200 CFM. Yes. And then for bullet point number 4 and 5, in the 2018 IECC were removed and replaced with these current bullet points. Spaces where more than 75% of the space outdoor air is required for exhaust or transfer air, where that air is either exhausted to other spaces, you got transfer air from that space with the makeup air coming in. And then in the 2018 IECC, there was an exception for spaces that required ventilation for process equipment. That's been removed in the 2021 IECC, and instead they've called out these specific usage types: correctional cells, educational laboratories, barbershops, beauty and nail salons, and bowling alleys, where DCV is actually potentially detrimental or not as effective. For correctional cells, you're looking at nearly continuous occupancy, so DCV doesn't really have an opportunity to dial back. For the other locations, you're looking at, even if occupants aren't in the space, there's chemical off-gassing and other things in use in that area that can emit VOCs and odors and things into the space. And so DCV would be detrimental in those situations because those things would be allowed to build up. And so DCV is accepted for those situations where that may occur. So this removes a little bit of vagueness from the 2018 IECC's exceptions and makes them a little bit more specific, with a slight adjustment on bullet point 3 there for a little bit more stringency applying those exceptions to your facilities. Looking at enclosed parking garage ventilation, again, the language here is most of the same with some slight tweaks to the stringency of the measures. In the 2018 IECC, garage ventilation could be accepted if the total exhaust capacity was 22,500 CFM or less and did not use mechanical heating in those spaces. In the 2021 IECC, that's been updated to 8,000 CFM. So again, significantly more stringent on that airflow target. Again, that has to be spaces that are also not using mechanical heating. If there's mechanical heating in that garage or applying energy to that space, then you still need to have some kind of DCV for that garage ventilation system. Looking at energy recovery system requirements, there is a new requirement that's been added in here where the IECC is kind of noting the difference between non-transient dwelling units and other commercial occupancy spaces. And so when you're looking at energy recovery requirements, non-transient dwellings, the enthalpy recovery of 50% for the cooling design, 60% for the heating design in our climate zones 4 and 5. There's an exception for the cooling side, enthalpy performance. It's whatever you can get when you're meeting the 60% heating design. With our climate and the enthalpy recovery for cooling for a dwelling unit where people are in there pretty consistently and they're creating humidity in the space from cooking, showers, things like that. That enthalpy recovery ratio isn't always attainable without significant expense, a higher efficiency system. So they're giving a little bit of leeway here with that exception for climate zones 4 and 5 for those non-transient dwelling units. For all other commercial spaces, it's unchanged from the 2018 IECC. All the same tables as far as determining when ERV systems need to be applied based on airflow and operating hours are unchanged. There were some updates to the exceptions, but none of them applied to the Illinois climate zone, so we won't go over those here. But this is that table again, just for reference. We've trimmed down the 2 tables into just the Illinois climate zone requirements. So if you're operating less than 8,000 hours per year based on your percentage of design outdoor airflow rate, you've got a certain target that will trigger the energy recovery requirements. If you're operating at over 8,000 hours per year, systems that are running nearly continuously, that airflow target is significantly lower. Looking at Guestroom HVAC controls, there's been a little bit of reorganization and clarification here. In the 2018 IECC, this was kind of a long paragraph that may have been hard to interpret from time to time. So what they've done is they've rearranged this in the 2021 IECC into bullet points that are a little bit easier to parse out and determine what each requirement is. The only thing that's really changed, though, between the 2018 and the 2021 IECC is that for unrented and unoccupied guest rooms, those set points should be adjusted to 80 Fahrenheit and 60 Fahrenheit within 20 minutes after unoccupancy is indicated by the network, where in the 2018 it was 30 minutes. So a little bit more stringent on that setback trigger time period. But otherwise, the requirements aren't changed here. They've just been reorganized into something that's a little bit more intelligible and easier to read. So when the units are rented, but they're unoccupied, you got to adjust the set point by at least 4 degrees within 30 minutes of the occupants leaving. So adjust the heating set point down, adjust the cooling set point up by 4 degrees. When they're unrented and unoccupied, then you've got those target kind of safety temperature settings of 80 degrees Fahrenheit, 60 degrees Fahrenheit. They can be sensed by a network controller, could be by an occupancy sensor within the space, detecting within 16 hours of continuous unoccupancy, will trigger those setbacks. And then when they are occupied, they need to return to those normal set points when that occupancy is sensed for the space. Could be the key card at the door, registration at the desk triggers a network controller, occupancy sensor in the space. There's different ways to manage that for guest rooms. And then our last major update to the IECC is the change in fan efficiency requirements. So the 2018 IECC used a fan efficiency grade. What they noted with those types of systems is that you could have fans with the same efficiency grade applied to different situations, VFD versus not a VFD, belt drive versus a direct shaft connection, different changes to the layout of fan systems. where you would get dramatically different energy performance for the same fan energy grade. So the 2021 IECC has brought itself into alignment with ASHRAE 90.1 and now uses the fan energy index for determining fan performance. And so you need to have an energy index of 1 or greater. VAV systems can have an index of 0.95 or better. So there's a little bit more leeway with those systems since they can have a little bit more control over their fan speeds and airflows. Otherwise, all the same exclusions for fan efficiency requirements are still included. Smaller fans and arrays of fans don't need to meet this efficiency requirement. Fans supplying higher temperature airflows used in an explosive atmosphere or environment, and emergency use fans that are only on very, very intermittently for testing and emergency situations. Since they're not in use very often, the efficiency of those systems doesn't need to be particularly high. They're managed. And then lastly, some updates for low capacity ventilation fans. So here we're looking at HRV, ERV fans, kitchen hood fans, bathroom utility fans, these smaller fans that are throughout facilities, kind of with the lower ventilation requirements. So for a mechanical ventilation system with fans less than 1/12 horsepower, this excludes fans that are part of a listed cooling appliance or other appliance that fans energy use is in the efficiency rating of that equipment. Dryer exhaust and range hoods that operate intermittently are also accepted from these requirements. These are for continuously operating fans. Excuse me. Some slight changes in the order of this table. In the 2018 IECC, electrically commutated motors with 70% efficiency and adjustable speed were included in there. It's been removed in the 2021 IECC. The section has also removed some exceptions that were previously allowed in the 2018 IECC. For those specific details, you can kind of go through that section. But the table has also been slightly adjusted where they've kind of grouped together bathroom utility fans into two categories here. That was kind of a general use category as a single row in the 2018 IECC. So they've made some slight adjustments to this table as far as looking up types of fan systems for these low capacity ventilation systems. So that brings us to the end of our presentation and our last poll. Our first question, which demand control ventilation exception was removed in the 2021 IECC? Systems with energy recovery, multi-zone systems without central automated controls, spaces with 75% or more makeup air for exhaust or transfer air, or where ventilation is required for process loads. And then for fan energy grade, does that account for efficiency of the fan wheel alone, while the fan energy index accounts for the entire fan system's efficiency? Is that a true or false statement?
See, we did have a few other questions come in, one of which is checking on the code requirements. What is the threshold for economizer? And that's over in C403.8.5 economizer. So individual fan systems with cooling capacity greater than or equal to 54,000 BTUs per hour. So in buildings other than group R occupancy. So if I recall 54,000, that would be 4.5 tons, approximately where that would be. Then, the 750 CFM threshold that you mentioned, Sean, question regarding, does it apply to each individual classroom unit ventilator or all the unit ventilators combined? And checking, it looks like the 750 CFM is for multi-zone systems. So individual unit ventilators would not have that minimum threshold. So the DCV would apply for individual unit ventilators. And another question regarding the ERV for Is that just for prescriptive or is that total building performance? Total building performance, so that's section C407. There is a section C407.2. There's a listing of requirements that are required even if you're doing total building performance, which one of those does appear to be that ERV. So that's what 403.7.4 and 403.7 all applies except for C403.7.4.1. So it's only 403.7.4.1 that would not be in total building performance. All the rest of 403.7 would be part of that.
Last note here, it's nice to see fan energy index in the code was pump energy index added as well. Not yet. That may be coming in future code cycles. But for the most part, the code focuses on specifying for electric motors. The motors themselves have to meet federal minimum efficiency standards, but they haven't specified pumping efficiency standards yet. Okay, let's go to our poll question, share those results. So our first question here, which exception was removed from the demand control ventilation requirements? It was the exception for process loads. So the last option there is the correct answer. All the others were maintained. They are still included, some with some minor variations, but only the process load exception was removed. And then fan energy grade accounts for efficiency of the fan wheel alone, while fan energy index better accounts for the fan system efficiency is a true statement. Looks like most people got that. So well done. Okay, if there are any other questions here in the last few minutes, please go ahead and throw those into the Q&A. But it looks like scrolling through the chat stuff that we've covered most things here. So seeing no further questions coming in, we'd like to thank everyone for joining us today. We hope it's been an informational session. If you do have any questions, specific project requirements, anything like that, feel free to please reach out to us at energycode@illinois.edu. We'll be happy to help you out. All right. Thank you all for joining us today. Hope you have a wonderful afternoon.